Another component to a daylighting system is a device to measure light levels. This would be a photosensor. You might have multiple in a space. And here's images of two examples. Again, it could be mounted to the fixture, or ceiling mounted is also an option. You need to have controls as part of your daylight control system to adjust the lighting to target light levels. And the image that you see on the screen, this is just a very basic image of some type of a lighting control architecture. So you can see it starts with a user-initiated device. That's going to be a switch or a dimmer. It could be an occupancy sensor, or it can be a photo sensor in the case of a daylight system that's saying we need to turn the lights off or down for some reason. It talks through a front-end protocol, and Doug will be talking much more in depth about controls, but it goes through a front-end protocol to an interface that then sends a signal out the back-end protocol to the power controller at individual luminaires, and the power controller is going to be a dimming ballast or a dimming driver or some type of ballast transformer that says to the fixture, hey, we're going to get brighter now, or we're going to get dimmer now, because that's what I'm being told at the front end. So you have this sort of architecture to control the system, and obviously if you're controlling daylight, you need to have controls. So remember, electric lighting to supplement your daylight system needs to be these 3 points: energy efficient by design, it needs to provide appropriate distribution and brightness, and it needs to be easily controllable, or it's not going to be a good candidate for use in a daylighting system. LED lighting is a very good candidate. However, not all LEDs are created equal. And please note that that's written in red so that you remember it, because we're going to say it a bunch of times today.